Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. This is the Math 8 edition, and I am Mr. Takeda. And this is lesson 4.3 on graphing proportional relationships. That's a big word, but it's something that I think we already understand. So let's go. First, this idea, what is direct variation? What is direct variation? Let me get my pen working here. What is direct variation? Okay, so in words, when you have two quantities that are proportional, now we've already studied proportions. We know proportional relationships look like things like A over B equals C over D. A proportion is when two ratios are equal. Okay, that's a proportion. Two ratios are equal. We can represent it by the equation y equals m times x. What does this mean? Well, that means we're multiplying. To get y, we multiply x by something, by some number. We know this better as a rate. This is some kind of rate. Now, we call it a rate when we're comparing units of measure that are different, but in pure algebra, there are no rates. I mean, there are no units of measure, really. So, we call this the constant of proportionality. It's going to be the same, I'm going to call it a rate, the same multiplier no matter where you are on your graph. Now, one thing that we know about a graph of direct variation or a graph, a graphing a proportion, is that it always goes through 0, 0. Okay, so that's always a point that we're going to have when we're graphing a direct variation relationship. Okay, so let's take a look at an example here. The cost y in dollars for x gigabytes of data on an internet plan is represented by y equals 10 times x. Okay, so if it looks like this, y equals m times x, we know what? We know that this is proportional. We know this is direct variation. We also know that one point that's going to has to go through is 0, 0. That makes our life really easy. So let's get this graph going here, graph the equation, interpret the slope. So I'm going to spread out the gigabytes of data here on the x-axis. This is gigs. I'm going to spread it out a little bit here. One every 4. I'm going to make that a gig of data. And then for the dollars, 1, 2, 3, 4, 5, every 5, sorry about that, every 5, 2, 3, 4, 5, I'm going to make worth 10. 1, 2, 3, 4, 5, that's 30. 1, 2, 3, 4, 5, that's 40. Okay, and this would be dollars on the y-axis. Oh, one point we have already is 0, 0. That is super easy. Now, any other point, I'm going to use x equals 1. Okay, so for x equals 1, y will equal 10 times 1. See, I told you this was easy. Y equals 10. That means that I can also graph the point 1, 10. X is 1, y is 10. So here's 1, 10. Okay, so there's my graph. That's it. So interpret the slope. So if I interpret this slope here, when it says interpret, well, the slope is just this 10, right? The slope is 10 over 1. That just means $10 per gigabyte. That's what the slope means in this case. All right, so there's our first pretty easy example. Let's see what's next. Boy, I can't wait. All right, so let's take a look at this word problem here. The weight of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. Okay, they're telling us this proportional. We know that means direct variation. We know a few things here about this. We know that that 0, 0 has to be one of our points if we graph this. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. There's that ratio I was talking about. Okay, but we also know that that this would be a point on our graph. This would be a point on the graph. Um, and what's our graph going to be here? Okay, X is the object on Earth, Y is the object on Titan. So Earth, Titan, right? So Earth, Titan. So Y above X. So 15 over 105. Okay, so that's going to be that's going to be the ratio we're looking at. But if we want to write the equation, we have to find what? We have to find M. And then we write Y equals M times X. Okay, so here's our ratio. And so let's take a look at it this way. So this is going to be one of our points. 105 is our X to 15 is my Y. I got that backwards. No, this is right. 105 is Earth, 15 is Titan. So this is Y over X. And then we know 0, 0 as well, right? Okay, so 15 minus 0 over 105 minus 0 is just 15 over 105. So if I was to simplify this, I could reduce 15 by 5, and I would have 3. I can reduce 15 by 5, and I'd have 21. Okay, so this will be 1 over 7, right? If I reduce this, I get 1 over 7. Right, so there's my M. That is the slope. That's my M. So I'm writing this. The equation would be Y equals 1/7 X. There's my equation. All right, so how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Okay, so again, Titan is Y. So in my equation here, that 3.5 on Titan, so 3.5 equals 1/7 X. So I substitute the 3.5 for the Y in my equation. I'm going to multiply both sides by 7. That's the reciprocal of 1/7. So 7 over here as well. And I know that this side will be X, and then 3.5 times 7, 24.5. So 24.5, and we're on pounds, right? All right, so that's kind of an interesting way to look at our understanding of direct variation and proportion. What's next? Okay, so we have this example. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5 times x. The graph shows the distance that a 2-person ski lift travels. Okay, so this is a 2-person ski lift. Which ski lift is faster? Well, we know for the four-person, it's going this 2.5. Okay, let's look at our units of measure, meters and seconds, that this is 2.5 meters per second. Now on the graph, we have to look at the slope to get the same information for the 2-person lift. That's going to be 12 minus 4. That's 12 minus 4, 6 minus 2. This is 8 over 4, which reduces to 2. So the 2-person lift only goes 2 meters per second. So which ski lift is faster? The 4-person lift is faster. Okay, so now we're asked to graph the equation that represents the 4-person lift in the same coordinate plane as the 2-person lift. Compare the steepness of the graph. What does this mean in the context of the problem? So, what do you think is going to happen if we graph the 2.5? What do you think is going to happen? Okay, let's go ahead and graph it. Now, because we're dealing with proportions, I know that one of my points is 0, 0. and that means I only have to really graph one more point. So what I'm going to do is I'm going to make it easy on myself. I'm going to use, so y equals 2.5 times x. There's my equation for this one. I'm going to use something easy. I'm going to use 2, because that way I can not have to worry about graphing that fraction, that half, right? So y equals 5. So what's my point? My point is 2, 5. So I'm going to graph that in red. So here's 2, here's 5, here's 4, here's 5, right here. Okay, so if you, when I asked the question, what do you think is going to happen when we graph it? If you thought that that line would appear above it, that it would appear steeper than the 2% left, then you were right, because that's exactly what happened. You can see our line for y equals 2.5x is steeper because we have that the constant of proportionality is the slope. All right, that's it. So this is good information. We will go over this in class again and try some graphing in class. Until then, thanks a lot and have a great rest of your day. Bye-bye.